name is Koch. I am the Vice President of Engineering and Innovation at Huber Engineered Woods, based out of Charlotte, North Carolina. Proud member of the Flash Board of Directors. This morning, we have three distinguished speakers who will help us take a look backwards at 2017 and some of the natural disasters that happened during 2017. The bios of each speaker are in the handout, so I won't read those, but I will just state their names. We have Bill Reed, who's a meteorologist, former director, National Hurricane Center. We have Lieutenant Colonel Kaitlyn Woods. I'm really anxious to hear from her. She's a hurricane hunter with the 53rd Weather Reconnaissance Squadron. And then we have Heath Hockenberry, and he'll speak about some wildfire issues, National Fire Weather Program Manager, he's with National Weather Service. Okay, as we were having conference calls and leading up to this segment, I was kind of scratching my head and saying, gosh, how am I gonna introduce this? And Bill chimed in and he said, hey, I've got the slide for you. And Sarah, if you'd forward that. This is the slide. And this shows 17 named storms that occurred in 2017. 10 of these turned out to be hurricanes, and a number of these turned out to be major hurricanes. So this just gives one snapshot, and I think a very powerful look at what happened in 2017, just from a hurricane perspective. We're also going to be touching on fires and other natural disasters, but this one just struck me when I saw this slide. So with that, I'm going to turn it over to Bill, and we'll start with his session.
Okay, good morning, everybody. Very glad to be here. I was just fascinated with Ken's talk and the approach there. I'm hoping some of what I show on last year's storms dovetails with what Ken presented. It's a cliche, I know, that we have very short-term memories of these disasters, that as time moves on, it fades from our memory. It's my hope that at least some of us don't forget the events that have happened in the past, because there's always more lessons to be learned the more we dig into what happened. Kurt showed the whole season there. I'm just going to focus on the three impactful storms that we had. Coming into 2017, we hadn't had a landfalling Category 3 or higher hurricane since Wilma in 2005, and I think the buzzword people were using was hurricane drought, though we had significant events. Sandy was a significant event. Irene, Gustav, and Ike come to mind in the post-term, but because we get fascinated with the breakover point between a Category 2 and a Category 3, we talk about the majors. These three storms combined did over $300 billion in damage in the U.S. and the Caribbean. More importantly, we lost way too many lives. Starting with Harvey. Harvey was my personal event. I'd worked four 40-inch rain events during my actual career and never thought I would actually be sitting in the middle of one of them. And Harvey proved me wrong, so I've actually now experienced 5 of these events. Harvey was a 2-event storm. First was the more classic rapid intensification to a Category 4 right up to landfall, doing all this activity in the Gulf of Mexico. On the top right is a picture when Harvey first became a depression. How many of you actually think people are going to take action based on that satellite picture and a forecast of maybe reaching hurricane strength at landfall? If you're correct in thinking not too many, most people are going to take a wait-and-see approach when we have a storm that bad. It's our dilemma in the Gulf of Mexico, in that many of the storms we face there that cause catastrophic damage go through a rapid intensification cycle in the Gulf of Mexico. We were very fortunate in Harvey in that the forecast that's shown in the middle there, the key forecast is 36 hours before landfall. The forecaster took the guidance he had, which showed a rapidly intensifying hurricane, jacked it up a little bit more, bringing it to a major hurricane at landfall. The timing was right on, the location was right on. Maybe it's a little bit less intense than what actually occurred, but it was enough that the decision makers made the right call in calling for an evacuation along the coast. And thirdly, on the forecast of the stalling and the heavy rainfall, I've never seen a rainfall forecast as ominous as the one shown in the lower left picture there, of a huge area of southeast and south central Texas experiencing greater than 20 inches of rain. And in the text, as much as 36 hours before the first raindrops fell in Houston, mention of perhaps rainfall amounts in the 30 to 40 inch range. While it ended up being greater than that, that was still a significant step forward to the kind of forecast we were able to do just 10 years ago. Harvey impacts. Landfall, 60% of the buildings were either destroyed or severely damaged, and as other speakers will address in the building code issues, there was distinctly a difference between the older building stock built to no code and the newer buildings there that followed some of the code recommendations we have. Another 60% figure, and fits right in with one of Ken's slides, is that 60% of the people that were ordered to evacuate, well, not ordered, in a mandatory evacuation, actually did so. It'd be very interesting to see if the 40% that did not go fit into your last two categories of people. And you're right, we all fit into one of those. I'm pretty close to there's a cloud in the Gulf. Donna, put the dogs in the car and get the heck out of Dodge. Over 200,000 homes were flooded between south central, southeast Texas, and a small portion of southwest Louisiana. Less than 20% had flood insurance. I don't have a solution for it. I think the messaging that would go out would work for me, but it obviously is not working for 80% of the folks. If you live along the Gulf Coast, you're almost at some kind of risk because of the extreme rain events that are possible. And Ken actually showed another one that wasn't even a named tropical system, producing greater than 30 inches of rain and massive flooding, again with people not having the flood insurance. 500,000 cars were flooded. Be very careful buying a used car these days. You're not supposed to resell those, but guess what, folks? They show up back in the marketplace. 68 direct fatalities. In light of the study that was done on the fatality issue with Hurricane Maria, it would be very interesting to see if similar type of mortality studies could be done on other storms as they come in, because I think we're underplaying the risk to human life that we have in hurricanes by not highlighting all the fatalities and all the significant impacts to health that occur post landfall of these hurricanes. And of course, the $125 billion in loss put it right up there with the other big boys we've had in the last couple of decades. Irma was a very different storm. It was a long-lived Category 5 and 4 hurricane that showed its hand well out in the Atlantic when it was still way east of the islands, which allowed for a consistent long lead time for U.S. impacts, and indeed even a long lead time in the Caribbean. The lower picture shows the consistency of the track forecast put out by the National Hurricane Center. That consistency allows more confidence in your decision-making process in calling for an evacuation. With the Florida Peninsula being in play from the get-go on the earliest 5-day forecast and leading on into the landfall, it allowed for long lead time evacuation orders, and an estimated 6 million people actually evacuated the peninsula at risk. What if Irma had formed in the Bahamas and not far out in the Atlantic? Do you think the orderly evacuation process, the same people are at risk, but do you think the orderly evacuation process would have actually occurred? One of my big concerns is always the ones forming close to land and rapidly intensifying. Impacts from Irma, devastation, Northeast Caribbean, westward to the north coast of Cuba, and severe impacts in the Florida Keys and the peninsula. The upper right picture is a picture of a before and after of the island of Barbuda, which was literally rendered uninhabitable. They had to remove all the people after the hurricane. it's hard to find a lot of news stories on how the recovery was going in those islands, but what I have, one interesting fact I did find out about that, in Barbuda now, of the 1,800 original residents, 1,000 of them have now moved back to the island. So progress is being made. The various tourist agencies there, you have to use that with a grain of salt, but they're predicting back to normal activities on the hardest hit islands sometime during the tourist season in 2019. So it does take quite a while to rebuild after one of the big events. And of course, the unfortunate loss of life and the large loss in dollar damage. That brings us to Maria, the third of our big impact storms. Now, this one was also a rapid intensifier. Went from a Category 1 to a Category 5 just shortly before making landfall in Dominica. Not well forecast. That diagram on the bottom left is the guidance that the hurricanes specialists have to look at. By and large, the guidance was showing 3 categories less, just 24 hours before impact on the island. It's very hard for a forecaster to go against that consistent of guidance, though. If you read the wording in the forecaster's discussion, there was concern that this hurricane could do a rapid intensification. As Ken pointed out, we still have a lot of work to do in the area of rapid intensification forecasting. On the other impacted areas, Puerto Rico and the U.S. Virgin Islands, this forecast was excellent. The track forecast was spot on from the formation point to landfall, both in timing and in location, and stayed that way throughout. So there was no uncertainty leading up to the landfall event that you were going to be impacting those islands, and the intensity forecast was for it to be a major hurricane when I went through there. So a very tale of two different aspects from the forecast, but from an impact point of view, you can forecast, Ken pointed out, we can forecast as good as we want, but we're still going to have, the hurricane's still going to hit, the buildings are still going to fall down, and if people haven't got a safe place to stay, unfortunately, we risk losing their lives. Just the pictures, that I can't even remember which islands or where some of those pictures were taken. Other than the bottom one, that is our National Weather Service WSR 88D NEXRAD radar, or what remains of it. It's supposed to be able to withstand the kind of winds that are were produced there. The question is, was it hit by debris? Once you compromise the dome that surrounds the radar, it's just like you compromise a house. When the wind gets in and blows out, bad things happen to the system. The radar was back online. It took it almost 10 months to get her rebuilt, and when it came back online late June, early July this past summer. There's controversy about the loss of life statistics in Puerto Rico, and in the Weather Service, we do our post-storm thing. We divide them up between direct fatalities, the ones drowned in the flooding, building collapsed on individual, tree landed on car. Those kind of things are direct fatalities. The indirect cover all the other things, and Ken showed the slide of Ed Rappaport's excellent study of how we come up with that. But the study that was done after Maria looked at this at an entirely different basis, basically ran a statistical look at the mortality changes area-wide in Puerto Rico from before compared to after, and came up with an estimate of how many people died, at least in part, due to the impacts of Maria. And it was a much higher number than what the direct showed. Be very interesting to see if we could work that into a systematic approach in the National Weather Service on all our events, because I don't think we should undersell the risk to life of weather events. And of course, we all know about the very slow recovery process when the place is devastated as badly as Puerto Rico was. So just some lessons learned. The track forecasts have achieved exceptional accuracy. I wonder if we're going to approach some limit sometime to how much better we can actually get at forecasting these. There's a certain amount of chaos in the atmosphere that the ever-increasing computer power and modeling may not actually capture, but I think those forecasts are good enough that if we can overcome some of the social aspects of different personality reactions to advice and decision, that the right decisions can be made based on the forecast track as it stands now. I've already mentioned that we need to improve on the rapid intensity. Ed told me that in the 2017 season there were 35 cases of rapid intensification, 7 of which were captured sufficiently in the models to make accurate forecasts on. The forecasters tell me 10 years ago the number would have likely been 0. So that shows we're making progress, but we still have a long way to go. Lessons learned on the social side from what I looked at. I sat in a meeting in 1990 out in Boulder, Colorado, and Bob Sheets, a former director of the Hurricane Center, relayed someone else's prediction of exponential increase in future losses from landfalling hurricanes based on population growth at the coast, lack of good building codes, and building in places that flood. And sure enough, we're verifying that with these near $100 billion events happening more frequently as time moves on. Demographers forecast that we will continue to rapidly grow at the coast. And guess what, folks? If we don't change our stance on building codes and land use in particular for flooding and storm surge risk, that exponential growth in losses will continue, and the $100 billion events, instead of being outliers, may become the norm in 30 years. People at risk are not buying flood insurance. We know that. Building codes work. We're going to hear a lot more about that in this meeting. Texas may be turning the corner on improving resilience. The several reports by the state, commissioned by the state, that go to the legislature this year call for actually having organized districts for building code and enforcement of those building codes, among a number of other recommendations. Ken already talked about this. A significant minority of the population choose to disobey evacuation orders. I lump all that into a term called denial. All those examples show that people are denying that the risk means them. And as 2 takeaways to finish up with, if you want an easy read book to read that gets into the denial aspect, this book, The Unthinkable, it's still available on Amazon for $15 or less. It's a very good read on why people do what they do in the face of the unthinkable, which a big hurricane is. And the Texas rain gauge is kind of a funny in there, but we just published new rainfall return frequency charts for Texas, and what used to be a 100-year rain event in the Houston area under the new guidelines is a 50-year heavy rain event. And that's just based on data. That's not addressing the causative aspect at all. That'll have serious ramifications for who's in and who's out of the 100-year floodplain, something I wish we would do away with altogether because it's not very accurate. Thank you very much.
I don't think I've spoken at a conference where I didn't go after someone that's over 6 feet tall, and I have to do this microphone. Do I have slides? Oh, I just click right through them? Oop, I sure do. Okay, as introduced, I am the Chief Meteorologist of the Hurricane Hunters, the 53rd Weather Reconnaissance Squadron. We're out of Keesler Air Force Base in Biloxi, Mississippi. And my topic's a little different. I was just going to, a lot of you I think perhaps have seen me speak in some form or not. So I was going to talk about our past, a little bit about our history, how we currently operate, and then a little bit of what we hope to see how we'll operate in the future from 5 to 10 years from now. And then I have some really good, cool pictures from the last 2 hurricane seasons to share. But our history started in 1943. It actually started on a dare. There was an AT-6 Texan, which is that small aircraft on the right. It was a single engine. And there was an instructor pilot that was in Byron, Texas. And there was a storm brewing in the Gulf of Mexico. And they were told they had to evacuate their airplanes. And there was bigger airplanes that were actually on the ramp at the time. This is where the story kind of forks. Some people say it was over lunch. Some people say it was at a bar. I've been in aviation long enough to know it was at a bar, without a doubt. But they actually dared him. They said, yeah, you think your airplane is so hot, go ahead and fly through the storm. And Colonel Duckworth said, I'm going to. So he picked a navigator, and no kidding, they penetrated a hurricane at 5,000 feet. They landed, and the navigator said he would never do that again. And Colonel Duckworth actually saw that the data that could be collected could be really valuable. And so he found the weather officer to go with him, and the very next day they did a second penetration, and they collected a ton of weather data, which they at the time sent to the Air Weather Service, and that is literally how weather reconnaissance started from that very first flight. So to give you an idea of the AT-6, that's our current airplane, the WC-130, and that's AT-6. So every once in a while, someone will say to me, "You're crazy, I can't believe you do that for a living." And I say, no, those guys were crazy. We have 4 engines, they had 1, and we have an airplane that can withstand severe turbulence, and they did not. So they definitely were very daring for that. Currently, we actually have 10 airplanes. That's how many fly operational storms. And we usually fly 24/7 when there's a storm that's getting close to the coast. So currently on the airplane, there's actually not 2, but 5 crew members. That's a picture of me to prove that, yes, my most frequently asked question is, do I actually fly in the storm? Yes, I do. I am very happy to say that I am the chief geek in the back. So up front, we actually will have the 2 pilots and a navigator. As you can imagine, the pilot's job is to get me home safely, which they have always done very well. And then behind them is the navigator who, yes, make sure we don't get lost, but they're also experts on reading the radar, because even though we fly through hurricanes, there are actually still things that we generally try to avoid, such as tornadoes and significant hail. And then sitting right next to me is actually, they kind of have 2 roles. They're called a loadmaster and the dropson operator. As a loadmaster, they're really in charge of the safety and the back of the airplane, but they also release the dropson, which is one of our instruments that we release in the storm environment, and they will collect the initial data in the airplane from that before they send it over to the meteorologist to quality check. Currently, we have 10 full-time crews and 10 actually part-timers that come in just in storm season to supplement when we get really busy. So in the past, when weather reconnaissance first started, it was actually global, and it didn't just actually fly the tropical environment. And now, currently, there's only 1 operational unit that actually does weather reconnaissance, and we only mostly fly the tropics, and that is my unit. We do have some colleagues over in the NOAA Hurricane Hunters. They have several aircraft as well, but they are more of a research operation. Currently, our area of operations is still fairly huge. It's very large for one squadron to take on, but it goes all the way to the international dateline, which is just west of Hawaii, to the middle of the Atlantic. And so we will pretty much fly any storm that forms in the Caribbean or the Gulf of Mexico up the Atlantic coast. And then on the west coast, it's mostly ones that are actually going to make landfall. So we call the storms that really don't affect too many people fish storms, because they're only really bothering the fish, and we don't normally necessarily fly those ones. So part of our mission, we start out at, currently it's called the low-level investigation. Believe it or not, we're famous for, flying through hurricanes, but actually this is the most dangerous thing we do. It doesn't sound as exciting, but the reason it's so dangerous is because we fly so low. We fly at about 1,000 feet, which is, some of these buildings in Clearwater probably aren't that much lower than 1,000 feet. So there's a lot less room for error when you're that close to the surface. And the idea is that the gentleman at the Hurricane Center will give us a call, and they'll say, hey, there looks like there's something brewing out there. They'll give us a very specific latitude and longitude, and they'll say, can you go tell us whether or not there's actually a circulation, or if it's, if there is not yet. I personally love these missions. To me, they're fascinating to see. We're looking at the sea surface to find out the wind direction and wind speed, and the idea is that we want to be able to see whether or not there's wind directions in all 4 quadrants or not. So if we don't find that we do have wind direction in all 4 quadrants, we go back to wherever it was we were operating out of and hopefully make happy hour. And then if we don't, then we turn into the very next actual mission, which is the fix mission. And that is the one that we're most commonly known for. So here's just a diagram of the fix mission. It's usually kind of an X pattern that we fly into. And the idea there is that we sample data from every quadrant of the storm, which I'm sure you all know the different quadrants can be drastically different. So we kind of want to be able to give the Hurricane Center an idea of what exactly is going on. This overlay is actually available to the public. It's a KMZ file. And it's only about 10 to 15 minute delay. So you can actually follow us operationally and see the data that's coming off the airplane. And this is mostly the flight level winds, but we also have collect surface winds as well with some instruments on the airplane. And it's about 105 nautical mile leg you'll see there. We're flying at 10,000 feet in a major hurricane. And then in the very middle, we send out an actual message called the Vortex Data Message, which pretty much has everything that's in the inbound leg collected. So what's in the future? You all saw that line, that X line. Well, as we all know, especially from this season, looking at Michael in general, that the storms are humongous. They're very large. So the actual amount of data that we're collecting is a very small sampling. We are happy to give that, but it is fairly small. It's just pretty much where we're at that very moment, and yet these storms are humongous. So in the future, we're hoping that we will be able to give larger samplings, and there's several ways that we will be able to do that. One of these is this picture that's currently on there, which is releasing a lot more buoys. The air and sea interaction in storms is something that it needs to be known more about, especially with the improving the rapid intensifying forecast. So in the future, we will probably be releasing a whole lot more buoys, mostly within the storm environment and also in front of the storms. And we finally just got approval actually to have that particular tube that's there to be permanently installed in the airplane so that we can actually release those kinds of buoys at any flight level, not just low level, which will increase our sampling. Another example is our radar imagery. So on the bottom right is our actual radar imagery right now. Two things that we'll see in the future is one will now be able to send that out of the airplane in the next 5 years. We don't have broadband communications currently, and we're working on that. So we'll be able to send those imageries directly to the forecaster at the Hurricane Center. For example, in a situation like Hurricane Harvey, that would have been really useful with the amount of rainfall that we had. In addition, though, that radar, again, it's a swath, but it's really just directly what's in front of the airplane. And the right-hand side is actually some data that came from the P3 airplane, our colleagues that over at the NOAA Hurricane Hunters. So we're hoping that eventually we can get another radar put on the airplane that will be able to kind of give us those vertical cross sections and more of a swath, and again, be able to send those out as well. And finally, the UAVs. There has been successful launches of UAVs out of the P3, again, not the WC-130. They kind of, the researchers, and they test stuff, but UAVs are the future in almost all of aviation. It wouldn't be surprising that they would be the same in the weather reconnaissance mission. These aren't UAVs like you think of with like a remote control. These are actually autonomous, and they will come out, but there's a lot of data, again, we can't sample. So some of them are projected to last as long as 5 hours. We'll see about that, but I certainly think a few hours would be good. In a hurricane environment, the Hurricane Center forecasters, their dream would be for us to fly at 1,000 feet, but we just can't do it for safety reasons. So these UAVs would be able to get down to those lower levels where it's important for the watching and warnings in order to tell the public what actually the weather is going to be like at the surface. I couldn't get this one to run this morning, so I'm almost thinking that the link might be bad, but I'm close to my time anyway. So here's some of the photos from this season. Actually, the last 2 seasons. So I'm still upside down from this season. If you ask me which storm I flew, I honestly don't remember at this point. I have to go back and sit down for a couple days and go through all my notes because we've just been really busy, and they happened really rapidly when they do. But there were some really amazing pictures. So this was Irma. And I believe that one's Maria. And I put this in there. This was not from the last 2 years. This was the first hurricane picture I'd ever taken. This was Hurricane Katrina. And Bill actually said every time he sees a cloud in the Gulf of Mexico that he tells his wife he wants to hurrivac. Well, in 2005, I was a student, so I definitely learned with a fire hose, and I flew Katrina. It was still one of the bumpiest rides I've ever flown, but we are from Biloxi, Mississippi, so more than half the squadron had a complete loss of home. A complete loss of home was a slab or over 9 feet of water. So 50% of us lost our homes in that storm, and that doesn't mean every single person that lived in the Biloxi area had significant damage to their home. So it kind of changed our perspective. Sometimes in the public forum, people think, oh, they just like flying storms, it's really cool. And it is, but not for a second do we not realize what is going on at the surface. And I would rather fly through a Cat 5 any day than to be on the ground. I can say that with absolute certainty. After seeing the aftermath, that I would much prefer that. It's a lot safer. That's actually a Pacific storm. This was shot this year. It's very rare to actually get really cool lightning shots like that because usually you're in clouds, so you can't really see it. And I should send it into the iPhone X because I think it was from an iPhone X. But it was beautiful, but it's also a little nerve-wracking when you know you have gas tanks on the wings. And I took this picture. This is from Hurricane Felix. That's actually the moon. It was a full moon, so it was a really unique picture. This was when it was a Cat 5. The actual eye was only about 4 nautical miles at the time, so very, very small. And the reason it was rapidly intensifying at the time, so there was so much lightning that between the lightning and the moon, it was like it was daytime out. And that's it for me. Thank you.
Back up. Let's see. Just the green one, right? Oh. Goodness.
You have to press hard.
Yeah, awesome. Looking back, I should have entitled this Crazy Weather Person Part 2. So being on the ground is fun too. It's I'd rather be on the ground facing that than up in the sky. So yeah, fire weather. To throw a little curveball away from hurricanes here. Just wanted to throw up our vision for the National Weather Service Fire Weather Program. Decision support. And the key is combined with resource and fire environment intelligence. Weather is only 50% of the equation. I liken our program to being a field goal kicker on a football team. We're not the most important people out there battling the fires, but they draw us in to win the game sometimes. So yeah, what is that slogan? We don't make the forecast products you buy, we make them better. Anyway, we try to make the firefighting better by our services. So that picture, that is me. I'm not sure. Yeah, I'm one of the 3 people standing there, and that's only 230 miles to the north here in the Okefenokee Swamp. So it is not just a Western event. We serve all levels of partners. Our direct agreement is with federal services, but we serve every state, counties, local people, anything that affects public safety we can forecast for. But again, we do primarily serve the Forest Service and the BLM, with a little bit lesser extent to the BIA, Park Service, and Fish and Wildlife. So what do we issue? What kind of breadth of services do we do? Red flag warnings, you might have heard of those. The origin of the red flag program is literally flying red flags in California up flagpoles to notify people in the public that it was a dangerous, or it is a dangerous day. I think some people in California are discussing the need for purple flags as we move into more dangerous wildfires as people build in the WUIs. We have to fit this all with other hazard services that are going on, and also that cluster graphic is actually our spot forecast program. We issue site-specific forecasts based on criteria that come into a local weather forecast office, 122 of them, and we tailor the forecast to that local area. So without getting out of the office, we usually receive a request for a forecast for a fire or a prescribed fire or a search and rescue event. This cuts across fire weather, and we usually turn around those forecasts in about 20 to 30 minutes. And I'll show you later, we're setting records there. We do pay special emphasis on our messaging to wildland fire safety. I think Michelle talked about Ready, Set, Go. That's critical for our partners and our local homeowners. And we do put out social media messaging and kind of the message of the day type of graphic forecast. That's in the bottom right-hand side of what you're seeing right there. So that's a quick way to convey to the public what we're seeing in terms of fire weather. Why do people need fire weather? It's just hot, dry, and windy, but we do directly serve fire management strategies. Resources are critical. What needs to be brought in, what aircraft need to be ordered, how many crews are needed for a particular event, and basically leading up to the decision of whether to evacuate or not. We don't make those decisions. That is obviously a local firefighter management call. So we even have wildlife and ramifications for the critters that are out there in the wildland. So we pay attention to those resources as well. The IMET program, how many have heard of the incident meteorology program out there? Well, we actually send people out of the office to fires. And that was why I was standing out there with that 20-foot wall of flame in front of me. We've been doing this since basically the fires of 1910. Officially in operation since 1929, so we're coming up on 100 years. So we basically pack into the size of a suitcase an upper air system, a laptop, a handheld Kestrel device, and we just go out with a printer as well and forecast right at the incident location. We've served about 3,500 missions, and there's 79 of us across the entire country right now, across 55 forecast offices. So there are certain areas of the country where obviously fire problems are more prevalent than others, so we position 2 people in one office. Sometimes there's a couple with 3, but our equipment is limited to the number of incident management teams that can possibly go out at one time to manage these fires. And every year we provide training on site. I'm out of Boise. I came here from the National Interagency Fire Center in Boise, so we provide that training every year for proficiency in using the equipment. It's like getting in the batting cage. Even pro baseball players take hacks before every game. So if we're not proficient in the equipment that we use the 2 or 3 times we go out a year, we're not effective immediately when we get on the fire. So we have to provide that training. So getting to the theme of the 2017 season, this is a graph that my partner Larry puts together. Larry Van Bussum is our operations dispatcher. So it's maybe hard to see, but the maximum, this is the number of times we go out during the year. And that black line right below the red one is the 2017 season. We ramped up really quickly in late June, and we went up quickly and served fires the whole way into December because of California. So some stats from 2017. Number of fires, we do name fires, but I saw the graphic of 17 named fires. We've got like 71,000. So it's mainly because of this area of the country too. It's the southeast that lights up a lot. Acres, 8.2 million. Damages, 18 billion. That's the source for that data is the Boulder. And 200 missions. That's the individual number of times we left the office and went to an identified fire out of the weather forecast office. So it's the second largest ever. We did 206, I believe, in 2006. And there's the statistic for our site-specific spot forecast. So when we don't leave the office, but we need to forecast for a specific spot, we did 25,870 spot forecasts. And the majority of those are for prescribed fire. They're not for wildland fire. They're for mitigating risk ahead of time when the agencies conduct fires on purpose. And those are the scarier type of things, actually. You put a match on the ground and you purposely light a fire and try to keep it under you achieve the management objective while keeping it under control. So where are we going in the future? The red flag warning is a key issue. Fire weather warnings are very much unlike other events in the Weather Service, where we don't verify red flag warnings based on occurrence of fires. We just basically find that the combination of weather events that are critical for an area, and if those things come together, whether there is a fire or not, and the fuels are ready to burn, that's kind of how we do that forecast service. So what we are looking to do is potentially scope out and find requirements for actually warning for fires that are occurring or are imminent, very much like tornadoes. So those questions that we have outstanding is, if we detect a fire, can we warn on those fire detections? And what makes sense to warn on and what doesn't? And also the public need for fire information versus fire management. We're very much a tailored to fire management type service, but with red flag warnings being out there and on the internet and on social media, they're obviously part of the dissemination and warning message from every broadcaster. And so we have to balance those needs. So it's an exciting time because of the GOES technology. We have the ability now in near real time to detect a lot of fire that we've never been able to see before because of GOES 16 and 17. We can see where they are at night, to very high resolution, the 2 to 3 minutes scans. And unlike hurricanes, you get a fire detection instead of having a few days to define your cone of impact, you have about 40 minutes. So the critical science involved, I believe, over the next 5 to 10 years and beyond is taking these detections, finding the radiative power of these fires, and throw a fire behavior model on it. Fire behavior modeling would have to be very fine scale and run in real time to be practically used in urban areas. So there is a lot of potential here, but a lot of computing power needed and a lot of communication skills needed if we find a fire and start warning for fire on the ground. So that's kind of the vision of where we hope to take the program in the future. That's all I have.